Hello, I'm back, and well, I've shown you the parts and the board that I was gonna be soldering, and obviously, like I said, it wouldn't make any sense for me to be filming me soldering components and showing a little bit of things soldered and soldering a little more components and showing, because the layout was already decided and there was nothing special about just like putting things in soldering them. So I guess you can see that I'm staring this way because this is where it is. So I guess now it's now that it is built, I guess that now it's time for me to show you. So here we go. Yeah, and let me zoom in a little bit. Try to position this. See if I can fix the focus. And there we go. So yeah, here it is, the PCB version of the YMK. So what's going on here? Well, first thing, I use the actual official version of the Arduino, and everything else pretty much is just soldering components, nothing special. As you can see, pretty much the same layout. One or two things changed, but it's essential functionality, everything is the same. I did have a few challenges with this, like I've shown before. It wasn't really fitting the holes, so it made a few mistakes, but luckily this one was easy to fix because the piece of the where the pins are. So basically all I had to do is I had to bend them in a little bit and then bend them down like this. So that one was long enough that I could do that, and the distance was not far enough that they just fit right, and I soldered them in, and that one was just okay. Now these were a little more tricky, the MIDI, because like I said, well, they were reversed, so I actually had to make this kind of ghetto style adapter. It doesn't look like pro, but it works. I mean, it's just a little prototype board with the pins offset to the right position. In the bottom, everything looks right, and it's like nothing special. It's just all the components soldered in. And on the top, like I said, there was just these two adaptations. This one is seamless, absolutely seamless. You can't see anything going out of place there or anything. And this one, you will see this little board here, but overall it works fine. And this guy got pretty solid here, so being able to connect and disconnect the MIDI wire without any issues. Now I guess what's left to do is to turn it on. So let's get on with it. And let me plug in the power, and let me plug in the audio wires. Here we go. There we go. Yes. The first thing that I was absolutely amazed what this PCB version had compared to the original one, it's how quiet it is. And oh my, it is quiet. So check this out. Turn it on. You'll load the patches, display the editor window, and what can you hear? Nothing. Check this out. Just a very tiny hiss, which is, I mean, basically it's probably more the computer hiss than anything. Well, there is some. Yeah, there you go. That is the computer hiss, and there is the hiss from this, but very tiny compared to the other one. Compared to this guy here, this old guy here, which, yeah, I say it's old guy, but I love it. It's the first, and it works, and it's great. But because of this, because of all this mesh of wires, what happens is there is a lot of bus wires going on here that get pretty close to where the audio wires come out, and it just causes a lot of interference. I even use like the final audio wire is like a shielded PC wire thing, but it wasn't enough. So it makes a constant like sound that comes from the bus that's always doing something, and there was nothing that can be done about that on that version. But on this one, because I made sure that the whole audio circuit is completely isolated from everything digital, even the ground, I don't know if you can see from here, but even the ground is isolated. There is a power source only for the audio that's different from the power source from the digital side. Well, the source is the same obviously, but I have a voltage regulator just for the audio side, and I have this one which is for the digital, gives the about 8 volts to the Arduino. The Arduino gives 5 volts to the rest of the digital components. And well, like you guys already know, I'm not a great player, so I can't do a lot of great stuff on this, but I did work on this version. I don't know if you can probably notice these switches here are different from the switches over here, and maybe I can zoom in and focus. Yeah, there we go. So as you can see, these switches, they are the rubber switches, and obviously these are the tactile ones. They make clicks, but these, they don't make any click. They just make sound. If I lower the volume and well, one, it's obviously to avoid avoid the clicking noise, and second is because, well, I intend to give this guy a shell, right, and actual keys. So it's just so that it makes the trying to focus. Yeah, I digress. That's how I am. Just so that when I'm pushing the keys, it feels natural. It doesn't feel like it's suddenly touch something and click. I don't want to be clicking the music. You want to be naturally pushing down the keys and feeling when it touches, that's when the sound comes out. And the way we are gonna arrange the hammers here so that when you push the key here, it feels natural, and this will actually act as the spring to keep the key up. But I have never done that before, so it's something that I have to learn. And well, so that said, it works. You probably noticed that the LEDs here I replaced. Maybe I can zoom in that side now. Just bear with me a little bit. Focus. Yes. You can probably notice here that I replaced the LEDs with the SMD LEDs, and that's actually true for many of the components. You see the resistors here by this 574, and capacitors, aside from the electrolytic capacitors, all of the ceramic capacitors are SMD components. So it looks much cleaner. The design looks much cleaner. Sometimes where I was able to solder properly, it actually even looks slightly like factory made. But for the actual chips here, I rather use the through-hole chips, and just so that it's something that I was already used to, and I knew it was gonna work, and I didn't want to complicate things too much. changing too much the way I was working before. This worked fine for me. And yeah, so pretty much that's how it looks. Much cleaner and much quieter. Now, one thing that I've been working on since I got this done was, trying to make it as much functionality as possible. And you are all familiar with the fact that it can play MIDI, and it has MIDI out, so I can use this guy to work as a MIDI controller. So I can press notes here, and it will react on any program, like a digital audio workstation or something. Or even if you use it as a controller for another keyboard, and it's MIDI is MIDI, so nothing special about it. And I also worked on the protocol to make it possible for other applications to send like through a USB wire data to the keyboard, and the keyboard would interpret it and play it. So what I did is basically a protocol that allows me to send data directly to the chips. And the implications of this is now anyone can design an application that will play music on this. And what could be doing that? Well, a tracker, for example. If you have a tracker that plays music on the emulated chip, you can, instead of using the emulated chip, play directly here. And as an example, I didn't prepare for this, but I'll be quick. As an example, I made a tracker for the Tito's Tito's sound driver, and if I launch the tracker without anything being attached, so right now it's a USB wire is disconnected, and I'm gonna go ahead and load the song. You probably recognize this tune from Sonic 3. So this is how it sounds with the emulated hardware. Just like you would expect, right? So right now I'm gonna close it. I apologize for my camera's own will to shut itself off. I don't know why it does it. It just does it. So as I was saying, I was just gonna close it, and now I'm gonna launch the application, and it connects to the keyboard, and I'm gonna go ahead and load the same song and play it. You're naturally gonna say, okay, it sounds the same. How do I know, right? So that's how you know. See this volume button here? There you go. So the drums are being played by the computer, but the rest is being played from the keyboard, and it works pretty well. So my next, obviously this is great because it allows you to try songs and see how they sound on the hardware, and there is always a special feeling about the sound of the hardware, of course, and there is always a little bit difference between emulated sound and the actual hardware. So as you can see, This allows me to just play whatever I want, which is great. Anyway, and I'm gonna do something interesting. I'm just gonna shut it down. And because it didn't send a stop command to the keyboard, and it will keep playing this note until it fades out, until I force it to stop. So once I thought about that, I said, well, this is great, because now can you imagine anything that writes sound to Yamaha 2612 can write sound to this keyboard, and VGM players, emulators, you know, anything comes to mind. So I decided to go on my own, and I found a VGM player out there that had open source code, and so I downloaded it and I modified it so that it would play instead of using the emulated chip, it would use the USB communication and send the notes to the keyboard. So this is how it sounds. So I'm gonna just pick it up, this song, and let me show you the interface. And if you're the author of this VGM player and you're watching it, thank you for having made this VGM player. It is certainly helpful for my development. I don't know if it's readable what's in the screen here, but basically I added here what it says, like it's using COM4, which means that it found the keyboard and connected. For example, I'm going to go ahead and disconnect and just launch it without, and you will see that it sees here using emulated FM. So it will always detect when it's launching, and if there's more than one COM port, it will let you select which COM port you're gonna use, but obviously I only have one on my laptop right now. So let's play, let's see what happens here, and let's go this one. Same thing, the drums are being played. Drums are being played by the emulator, just so that I show that it's possible to mix the sound, and also because when you send drums over the serial port, it tends to slow down. So that's how I dealt with it. Just mix the sound. So that's another application. Stop this, and this one doesn't send us stop command. So I'm just gonna go here and force the keyboard to shut down. And the very cool thing in my experience here. Let me go to, if I have a folder full of VGM files. Yes, thanks to Tito for those. One thing that you might not have noticed on those, and I'm gonna go ahead and show it to you again, is what about the PSG sound? I clearly don't have a PSG chip on my design. However, if I play this song from Shining Force, and Shining Force is a game that is very PSG intensive. So here we go, Wandering Warriors, setting 1, 2, 3. Listen, PSG. And no, I'm not using emulated PSG. I'm just gonna go ahead and lower the volume. Pardon me for not shifting the camera, but there you go. So what happens is that I allocated, I have 2 chips, right? So obviously, oh yeah, let's see a PSG. So I have 2 chips. In a normal VGM for Mega Drive, Sega Genesis, you have one 2612 and one PSG chip for making sound. So I know for a fact that no VGM is gonna allocate more channels than a 2612 would have. And I had another 2612 there to do whatever I wanted. So I programmed my software here in the Arduino to receive a PSG data, translate it to the 2612, and then I created a patch that sounds exactly like a square wave. And the result is this. Basically, they will play together just as if this was a PSG chip, and like I just showed to you, it sounds pretty convincing with the vibrato and everything. Okay, this time I got the card full, so my card that I'm using to record this right now, it's gonna get full again because I only deleted a few videos that weren't that long. So I'm gonna try to speed up through what I have to say here and hopefully clean this card for the next video. So anyway, so as I show, basically I was able to recreate the PSG sound using the actual FM chip. That's the beauty of FM. You can create very complex or very simple sounds out of it. You can make it sound the way you want. So it's pretty amazing, pretty remarkable. Now, the next thing I did is I implemented the ability to play VGM files directly on the keyboard itself. So right now it's still not fully on the menus or anything, but I'm gonna go ahead and disconnect the USB wire here. So you see the keyboard is 100% standalone. Yes, so there it is. So no USB wire here. So keyboard is standalone. So what I do is I select the tune that I want to play by selecting the instrument with a number, and then I'll hold this key here and reset. And when it resets, if I'm holding this key, it loads as a VGM player. And that's another tune from Shining Force 2. Like I say, it's pretty much PSG intensive, so it's great for me to be able to test both sides, like having PSG or having FM. Since I don't have much free time on this video, I'm gonna go ahead reset this since I already showed the Shining Force song. What about a PSG only tune? Yes, we thought of that too. This is a Master System PSG file. Does it sound like PSG? Now, anyone who is very familiar would notice that the white noise channel isn't quite right, and that's because on FM I didn't find a way to pitch the white noise, so white noise always sounds like the same hiss, but it's still it's pretty cool because most of the songs that use PSG white noise on the Mega Drive use it for hi-hats, which is usually high pitch like the one that I'm being able to make right now. And here's another remarkable song from the Mega Drive, and it's playing straight from the BGM file in the SD card. It sounds great. That's what FM does. Great music. Okay, so I don't know if I have enough time on the video, but just play a little more. This song is so great. And I will actually, let me say this. I will actually record all these songs one by one and post as a video, like so that we can just hear the songs and hear how they sound. I hope I have enough time on video for this one because, you know, all massa usa koshiro. Okay, I was able to squeeze in a little bit extra time on the card, so other than that, the last thing I wanted to go through is the MIDI playback. So let me restart so that it goes back into the and like I already showed, MIDI is nothing special. You already know how it works. It's just because, you know, I like playing Chrono Trigger songs on the Mega Drive chip, and I think I already played this one, so forgive me for that. And oh my god, I hope I don't run out of time. Yes. And here we go. So as you can see, you can just load a MIDI and have it play. So that's it. Many ways to play music on it. You can have VGM files on the keyboard, you can stream VGM files from a VGM player, you can play music from the MIDI, and in the future I'm gonna get a tracker going here so you can actually make music on the keyboard itself and have it play. Finally, like I said, emulators. If you wrote an emulator and you want to adopt my protocol to send the commands through the serial port, we can actually have an emulator playing music through the real hardware, which is quite exciting in my opinion. So that's it. I'll end the video with this song, since apparently I still have a few seconds left on my card now that I deleted a few more videos. And thank you for watching. It's always a pleasure to be reporting my progress on this project and to have you as a company. See you next video. Bye bye.